Hi, everyone. Thanks for joining this MLOps webcast by Thorogood. I'm Andrew Kennedy. I'm a consultant with Thorogood. Been with Thorogood for about 7 years, and today we're going to look at how we can use MLOps approaches to optimize the data science project lifecycle. The aim of that being to deliver more value and faster. Before we get into the meat of today's topic, I'm going to briefly introduce Thorogood for those of you who haven't come across this before. We are a business intelligence and analytics specialist consulting company. We deliver value across a range of points in that project lifecycle for business intelligence and analytics, everything from strategy and roadmaps through solution design and development, planning and business modeling, data and analytics services, through training and empowerment, and then following on from the majority of our projects with maintenance and support afterwards as well. And we do that for large global customers by delivering out of our global units across London, New York, Philadelphia, Bangalore, Singapore, and Sao Paulo. And across all of that, we focus on kind of three key pillars of the work that we do. We keep a strong business focus and bring in alongside that technical capabilities and our strong analytics knowledge to deliver value by bringing more wisdom out of your data. So for today's topic, we're going to take a look at MLOps and talk about, I guess MLOps really is looking at how we apply DevOps principles to machine learning. So to start on that, I guess a good place to start is to take a look at what we mean by DevOps. Take the definition here from that previous webcast that we've published on DevOps. And that definition here is to position philosophy and technologies to streamline the software delivery lifecycle. I'll dive into that in a little bit more detail, but the core here is we're trying to achieve a few different goals. What we're trying to achieve, we want to reduce the time to deliver value. So how do we speed up that software delivery lifecycle so that we can deliver value faster? By moving faster, we allow ourselves to respond to business opportunities more quickly. So we can move faster, move at the speed of business. Typically, if you think about some of the opportunities that are coming in, at times there are if a competitor changes their strategy on something, we want to be able to respond to that in maybe even just a couple of weeks. And if we can get our software delivery lifecycle short enough and tight enough, we can respond to that in a really timely manner and respond to those opportunities as they occur. Also then, by moving faster, we deliver a step change in productivity. And we'll see that some of the things that we talked about for MLOps as well are aimed at making more of what we do reusable, so that we're not just doing things faster, but we're doing things smarter as well, so that we're able to deliver that step change in productivity and really deliver more value at higher speed and realize the business opportunities that come from that. That's what DevOps is trying to achieve through a mixture of technology and then philosophy, really meaning a combination of the people and the team structures that we have and putting that in place alongside some of the processes that we have and how we optimize the processes to make sure that the steps, the goal gates that we have in place in our various different processes are really serving the purposes that they're there for and helping us to deliver more assuredly, but deliver faster as well. So what we want to do is take the same approach and apply it to machine learning and the data science life cycle. So let's take a look at data science project lifecycle. Now this is a really simplified view of what it looks like. Different groups have slightly different versions of the life cycle that they follow, but one thing that's common across them is you'll see iteration across a number of steps. Often these kind of diagrams have a little loops in where you note that you'll go from one step into the next step and then maybe go back to regroup and review. I've simplified this down into a kind of linear view because I think that helps us to take a look as we go through today's session and think about the changes we can make at each of those stages. But what I've tried to do is capture all the different steps here, even if I've laid them out in a more straightforward fashion. So typically our projects will start with a mixture of business understanding and data understanding. So business understanding really being a stage where we stop and look at what are the business questions, what are the high value business questions we want to try and use data science to answer. We then take a look at the data and see how well the data supports that. And I guess the key thing we're trying to draw out in those two steps is to find the high value business decisions that we think we can make big improvements on the decisions we're making by leaning on the data that we have and applying some machine learning and data science to do that. From there, we enter into, I guess, what might be traditionally viewed as the kind of data science, the data scientist realm of looking at the exploratory analysis. So what is there in the data? What hypotheses can we come up with that might start to answer those business questions we identified at the start? There, once we understand the data a little bit better, we've seen the hypotheses, we start to prepare the data to actually start to build out the machine learning models. And we enter that modeling stage, and we'll try and test maybe tens of models and a lot of different iterations of the different models that we might use. From there, we want to evaluate both the model and the accuracy of the model and how well it answers those business questions, how well we can rely on it, but equally how much value it's going to give us on actually answering the business questions that we set out to answer at the start of our process. From there, if evaluation goes well, we go on into deployment and look at how do we take a machine learning model and make sure that we're deploying it to the end user so they can use it to improve their decisions. And finally, the monitoring and review stage, once it's in deployment, we know that a machine learning model, we need to check that it continues to deliver the accuracy over a period of time, and that the value typically isn't a one-off thing. We want that value to continue to be delivered. And even as the data changes, we need to check that the model put in place is giving us the accuracy and the value in answering those business questions that it did when we first evaluated it. So that gives a sense of the data science life cycle, and that's what we're going to look at optimizing. I guess one key thing I want to draw out of that is to say that we've looked at DevOps for software development before. Now we want to look at MLOps for machine learning, and there will be some differences in those that come out of differences in what it is that we're trying to achieve. You know, the strapline at the top there, data science isn't just software development. So software development, DevOps is trying to achieve a few things like a consistent code base. We have functional testing, and the DevOps principles and practices quite often, you'll look to automate a lot of that testing. Deployment, again, something that we want to kind of operationalize and automate as much of that deployment as possible. And then coming out of it, the monitoring is typically looking for software faults. So the test will be, does it run and does it do what we expect it to do? In machine learning, we've actually got to go a step above and beyond some of that. So thinking about if we have a consistent code base in software development, quite often that will go some way to making sure that every time we run the build processes, we should get the same piece of software out at the end. So the same code leads to the same piece of software. Machine learning, that's not always the case, depending on how we build it and how our data is coming in. Usually, we'll build a machine learning model at one point in time, but then when the data changes and we retrain that model based on the new data, we get an updated model. And so it's really important. I'm going to argue it's even more important sometimes for us to have that consistent code base and make sure that we have that ready to rerun on the new sets of data that come in, to make sure that we're able to update the model and get the latest version of the model that supports better and more up-to-date analysis based on the latest trends that we're seeing in the data. Off the back of that then, our testing and our validation isn't just about functional testing. It's not as simple as saying if we put A in, we expect B out. Because those models are changing, we need to think about how the model validation will react to that and allow for the fact that a specific input might generate a slightly different output depending on the data that we've used to train the model. But we still have a lot of validation to do. We know quite often that we want that prediction to fall within a certain range. And so rather than thinking about it being a certain input leads to a certain output, we want to think about how much tolerance do we want to give before we actually say, no, wait a minute, we have to have a human take a look at the model and take a look at what's changed and understand why those predictions are coming out differently. So it's tolerance and ranges often, and so we need to think about the validation slightly differently, but there's still a lot we can do to automate some of those checks and tests, even if sometimes we're going to pass it over to a human at the end to have the final say on that. Call down model deployment and app deployment, there are some differences in there. Largely, though, we're talking about software differences. So if you're building a machine learning model, we're looking at things like R and Python, and so we need to look at, or other machine learning tools, we might want to look at how they play into the software landscape that we've got, and if we've got DevOps tools, how do those play in together? We're going to talk a little bit more about the technology in deeper detail later on, so I'll leave more on that as we come to that section. But finally then, when we come to monitoring, like I say, in software, often we're monitoring for faults. Is the software still running? If we give it input A, does it still give output B? With machine learning, we're monitoring for accuracy. We expect it to take new inputs, new data. We want to check that it's giving outputs for that. But we want to check, as far as we can, that data still sits within the range that we expect. Thinking about the changes in the data that are coming in as well, we want to monitor for kind of data drift, especially if we think about the things that have happened in the last couple of months. There'll be a lot of changes that are happening in the world and in the inputs that our models are now taking in. We need to be doing monitoring for accuracy and checking, do the models that we've built still hold after all the changes that we've seen in the real world that they're meant to be modeling? And then for those models where there's a change, we've got to think about the model retraining step. And is that something that we want to automate? Is that something that we want to kind of trigger alerts to get our data science team to take a new look at some of these models? So just a brief think there about some of the things that we could be doing in machine learning, picking up some of the ideas from software development and the ideas that have been brought from DevOps, but taking them into the machine learning and the data science project lifecycle. How do we think about getting started on some of this? Whenever we applied DevOps, what we were doing was to take the software development lifecycle and look at what are the optimizations that we can put in place there. And so really the key thing we want to do here is do the same thing. So let's take a look at the data science project lifecycle. And I'm very quickly going to step through a few of the different optimizations you can think about with this. Just in the interest of time, I'm not going to dive into too much detail in these, but I'm very happy to pick up with people after the session if you want more of a conversation about what your data science project lifecycle looks like and where some of these make sense or other things might come in to help you as well. Standard template scripts as a first thing that will help across, particularly I think data understanding and exploratory analysis. Often those first steps, the first things that we do in some of these model building processes often look very similar. So can we build the template scripts to get us started? Obviously then each project differs from that point. It differs after the first few steps, so we'll need to build them above and beyond. This isn't about automating everything that the data science team do, but if we can build up our template scripts and use those to rerun the common steps across them, there's a lot we can do to give ourselves a kickstart into the project lifecycle that way. Building on top of that, then code sharing and versioning is important. So if we build something once, we want to be able to pick that up and reuse it again. Equally, I think some of the things thinking in the past has been as we do exploration, we can build it in sandboxes, and we do a lot of throwaway modeling and exploration. Actually, one of the things to think about is as we're experimenting with machine learning models, we should be building up a whole catalog of experiments and the learning that we have from each of those. Something that doesn't work today may be important information for when we're going to build a similar model in the future for either another business unit, another country. Maybe we're looking at one brand now, we'll look at another brand later on. If we're looking at one insurance category now, we'll want to take a look at a different insurance category later on. And whatever information we've built up on what we're running at the minute, the experiments that we're trying out now, will be useful for us as we come to see that later. So keeping that history and that version tracking of what we've done in the past can be very valuable in saving time for us later on. Equally, sharing derived data sets between projects, kind of oft-cited statistics that I don't know how much actual evidence there is behind it, but I've often heard it said 80% of data science is data engineering. Whether there's science behind it or not is definitely a common thing to see that a lot of data science time is spent getting the data prepared and getting the data ready. So there's an importance to sharing some of those interim derived data sets between projects so that we can reuse as much of that valuable work as possible. Similarly, on the models, we want to have a searchable model catalog. Can we see what's been done in the past? Can we see if I'm building a model up for my country now, has someone else in the same organization in a different country tried building the same thing before? If we've got a searchable model catalog, I can very quickly run a search on some of the key terms that make sense for the model I'm building and see, has someone else done something that I can leverage and build on? Equally, if I'm coming back 6 months later, I might know I built a model a while back, but can I find it? Where does it sit? If we've got the searchable model catalog, that's something that helps us on that front. Automated evaluation steps is something that I kind of talked briefly about before. Whatever your evaluations, there's likely to be a common list that you're going through. If you're building out for one model, maybe last minute we think about something different, we change the model that we're using, we're going to want to run all of those evaluation steps again. So rather than having to go through and do that all manually, can we build up at least a test script and then automate as much of that as possible? So maybe we have it all set so that it runs when I press a button, or maybe I actually have to step through the steps in the script, but at least if it's there in the script, I can do that slightly faster. And then from the kind of fully automated bits, the things that need human intervention, can we give a central place for tracking those different steps so that maybe we've got 6 or 7 different testers who have to evaluate for different things. Data scientists who are checking the accuracy of the model. I've got business users who are checking that they understand how to use it. And maybe we've got kind of review teams from IT or data security who want to take a look at what data it's using and what sits behind it. And they've all got different evaluation steps that they need to go through. If I can track that in a central place, I can get much faster feedback on things that need to be checked or updated. And if something does need to be updated, does that then pause all the other testing? Can other people still go ahead and test some of the aspects? If I need to get people to repeat certain testing components, having that central place to track it and understand where we are in the testing cycle, and again, get that much faster back is something that speeds up the process of in deployment. Then, how much of that cycle can we automate? Ideally, we'd love to have it in place that once the evaluation is complete, it's a case of pressing a button and the whole thing gets pushed into the architecture, into the infrastructure that supports it. So how much of that process can we automate? And that's something that we'll take a bit of a look at in the technology demos later on. Monitoring and review coming out of the back of that. We want to have lots of monitoring in production. So calling out, I guess, not just the modeling outputs, but also the modeling inputs. So what are the new data sets that are coming in? How do we track the data that's coming in production? How do we track the outputs against the inputs? Do those match and do those give us the levels that we expect? And finally then, in terms of using the outputs of that, if we have that monitoring, what happens if it flags something up? Do we use that to kick off an automatic retraining cycle? So do we automate the whole process so it rebuilds the model, retrains the model in the new data? Or do we want some sort of alerting system that pulls the data science team in and allows them to rebuild the model, reuse those scripts they've had from before? So we're doing something similar to the automated retraining, but allowing humans in the mix to review and catch where things have changed and maybe give it a slightly more review. So I think a little bit more in some of the considerations, but that's something to think about is how much you trust the automated process and the different things that influence that depending on your use case, depending on the business restrictions that you have in your organization. So a long list of things I called out there. I have a bit of a think now about how we use technology to enhance those processes. Just to call out, there are a few different kind of spheres that we can be pulling technology from. Thinking about some of these different things, we just put up on the screen. Some of the things I've used different phrasing, different wording in some places, but thinking about some of the things that we talked about there, how do we use technology to enhance that? And first off, I guess it follows on from the fact that really we're doing something very similar to what we were trying to do with DevOps here. For MLOps, there is an overlap with the DevOps tooling. We'll take a look at that in a minute, but thinking about things like code sharing and versioning, a lot of machine learning tools are now building in capabilities to interact with the likes of Git and some of the code sharing and versioning that brings along. Equally, for something like continuous integration, continuous deployment, we'll see how some of the tools that were used for that can now hook in with some of your machine learning tools to give you similar capabilities for MLOps. Other components in this come as optimisations in the data platform. So thinking about the data catalog and how we share those data sets. Once we've done our work to get the data set in the format that we need for analysis, how do we share that and make sure that it's available for other users? That's something that we need to think about as part of our data platform. And monitoring the data as it changes coming in, again, that's something that we can build into our data load pipelines and run as part of our data kind of ETL processes or data load processes. And then sometimes there are places that we need to go above and beyond the technology that we've got at the minute and build in new tools or ideas for MLOps. So thinking about model experiment tracking in particular, that's one that a number of machine learning tools are building in fantastic new capabilities for. So if we think about something like Databricks, one of the technologies that Thorogood partners with, Databricks open sourced recently their MLflow technology, which is now being implemented across things like Python and R as well as Databricks. So it's something that you can use to keep track of model experiments. Equally, Microsoft within their Azure Machine Learning tools have built their own model experiment tracking, which is compatible with MLflow but builds on top of it as well. And that's something that in just a minute I'm going to get Jaswy, who's on the call with me, to demo for you. Like I say, we'll take a look at some of these technologies and how, one example of what that might look like with some of the Azure tooling. There are plenty of other sets of tools available, and depending on what you're using for data science, depending on what you're using for DevOps, we're very happy to have conversations outside this call to help you understand what sort of tools might be available and how the combination of tools will work to best serve your needs, helping your data science team to optimize the processes that you're working within. But to take a look at this and just to think about how we use some of these tools, I want to take an example of something that the team have been doing before. So here we've got a set of existing teams that are using a mixture of R and Python code to build out some machine learning models in Databricks. And Databricks, as a tool, has some code sharing and versioning capabilities already built in. So that's something that this team have already been using. We want to keep using that capability going forward. But here we're bringing in, alongside Databricks, we want to bring in some other machine learning tools like Azure ML Designer. And that might, Azure ML Designer is something that's drag and drop compared to the kind of heavy code R and Python approach that the data scientists might want to take. Maybe we have some citizen data scientists or people within our teams who want to get more hands-on and use something like Azure ML Designer that doesn't require the same level of kind of coding experience. And so if we're going to do that, we might want fair tracking of all the machine learning experiments, and in particular, a central store for all of our validated models. It's whatever approach we use, and we could use something like MLflow from Databricks, or we could use the Azure ML tracking. We'll want something that has a central store that will allow us to store details of the experiments from both Databricks and Azure ML, and both of those will do that. Deployments then, we want deployments to be managed through a single tool, and this is where, in this case, we're setting on Azure ML as our approach, because it manages deployments into the Azure ecosystem using Azure Kubernetes service. It doesn't really matter for this webcast what we're deploying into, but just think of it, the deployments are all managed through Azure Machine Learning. So just something we've got here from the Microsoft kind of take on their tool and how you can use Azure Machine Learning alongside Azure DevOps to deliver MLOps. So at the top, we've got there what the Azure DevOps tool does for kind of software development lifecycle. So we've got collaboration using Git and GitHub. From there, you build pipelines to build the app, testing plans to test the app. So that will include both automated and manual test steps. Then a release pipeline to deploy the application, and then going forward, you monitor it using some of the Azure tooling. For a data scientist perspective, we're going to reuse some of that code, like I say, code sharing and versioning. We want to reuse things like GitHub or some of the other Git platforms to keep track of the data science machine learning code that we have and some of the environment versioning. So Azure Machine Learning will allow us to do that. Just right out of the box, has collaboration and integration with GitHub. From there, we can make use of the build pipelines to train our machine learning model. So once we've got that code built up, we can test it locally on our own machines, but we'll build it up in such a way that to kind of build the official version of the model, we'll use a build pipeline. And that way, we've got tracking, we've got logging right through that build pipeline to be able to say, this is the version that we're using at this point in time, this is the code that built it, this is the data set that went in, and we're able to track all of that through the build pipeline. For the evaluation steps, we use a combination, again, of Azure Machine Learning and its model validation profiling options, while using the test plans in Azure DevOps to keep a track of that and take those test steps and do the monitoring and logging on that. So we've got a kind of central consolidated repository seeing the different tests that we ran. From there, we deploy the model again using a release pipeline. So here it's all about using Azure Machine Learning to package up the model. The Azure DevOps and Azure Machine Learning combined gives a really simple way to hook those two tools together and automate that deployment step. So you can just press the button and the machine learning model you train in the build pipeline gets deployed into some of the Azure tools. And I'll show you what those steps look like in Azure DevOps a bit, but they've really simplified it down into a kind of graphical step-by-step pipeline process. Where it differs a bit then is in some of the monitoring, and here is where Azure ML really steps up and gives capabilities for model management and monitoring, and in particular things like data drift. So it will allow you to track as new data points come in, as you're predicting on those new data points, it will monitor those. And when the data set changes enough, it will give you some of the triggers into Azure DevOps to build a new model, kind of repeat the cycle, or you can get it to trigger an email. So just when the data set has changed a lot, when you see there's been a change in the inputs that you're seeing, you have that flexibility to have an email and just see that the data science can then pick up and say, okay, we need to do something here, we need to change something. So depending on the level of automation you want, there are different capabilities that you can run from that. So you see there's a whole cycle that we can kind of end up in here and retrain the model, update the model through the cycle. And that's all built by using a combination of Azure Machine Learning and Azure DevOps. So we'll take a step back and look at the scenario that we're talking about here. So we're starting with teams who are using R and Python code to build models in Databricks already. They want to continue using Databricks for its code sharing and versioning capabilities. What we're going to want to do here is hook Databricks up with the Azure Machine Learning experiments and model tracking. So in just a second, I'll get Jaswee to demo for us how we can do that. How do we start with R and Python code we've got in Databricks and in as few steps as possible, almost hook that up to Azure Machine Learning so that without too much of a change for our team, we're able to make use of those new capabilities and start building in some of the MLOps thinking and methodologies. So we're going to do two demos now. I'll get Jaswee to do that very kind of that high-level demo of how we take one step from the code that we're building at the minute to bring it into those new toolings and get some of the model metrics that we use from that. And then I'll take a deeper dive into what might the kind of more full adoption of MLOps look like in terms of building into Azure DevOps, building out the new technologies and new capabilities for automating a lot more of this process. And then we'll have to think about how we can get started with some of this. Jaswee, over to you.
Thanks, Andrew. Hi, everyone. My name is Jaswee. I've been at Thorogood Associates for about a year and a half, and I've had the opportunities to work across span of technologies like multidimensional cubes, .NET, and of course, machine learning, Azure ML, and data science opportunities as well. We'll quickly dive into Databricks. So our first step would be to connect to the Azure ML workspace. So to do that, you would also require your subscription IDs, all the IDs and resource group IDs from your Azure portal. We'll first import a few libraries that we need to connect to the workspace. The next step would be to connect to the Azure ML workspace. And then what we would do is we would create an experiment. If an experiment was already created, we would create a run of that experiment. So in this case, I already have an experiment created called Explore Runs, and I'm creating a new run of that experiment. As soon as I create a new run, I also get a link for that run. And what that link would do is it would send me to the Azure Machine Learning Studio directly, and I would have my run ID. So it would essentially show me the current status of that run. It's currently running. So this is currently me viewing an older run which has completed. So if it's a new run that you've just initiated, it will be starting or in progress. You could also see the current metrics, images, output logs, etc. So here I have created a new run, and if I click onto this, I'll be going to the same link, but to a latest run. And if you see when it loads up, it's showing running here. Now, the next step would be to connect to a data store and load your data set. You could also do that locally, but we're using the data store and data set from Azure Machine Learning's inherent capabilities. So here I have a data set uploaded already in my data store with a car.csv file. It's basically the insurance data set, which tells you what are the frequencies and the amounts of the claims that the insurance company receives for the cars. And the next step would be to clean out the data set, basically remove a few columns which I don't want, basic processes that go into your data science experiment. Once that is done, I would split my data set into a train and test or a train and validation. I am then creating two models. One is a frequency model and one is a severity model. Both of them are linear models here. And the frequency model is essentially the number of occurrences of insurance claims that happen for a particular vehicle with an age, an area, and a category. The severity is the amount of the insurance claims. So once we create both of those models, we would want to classify those models in a more explanatory manner. So what I'm doing here essentially in the next step is adding a significance to each of the parameters that I've received or the coefficients that I've received from the linear model. We're using the similar approach, that's statistical approach, where look at the p-value of each of those coefficients, and based on the p-value we assign a significance. So if my p-value is less than 1,000, I am giving it 3 stars, which means it's highly significant, and similarly to 1 and a dot, meaning it's not significant at all. Now, why we want to do this is we could also log these into our experiment, so we won't have to come back to a notebook and look at what the significance was. We could just go back to the Azure Machine Learning Studio for our run, and these coefficients and their significances would be logged off to the experiments. So once we log off the coefficients, we can also see them in our Azure Machine Learning Studio into the outputs and logs and the metrics. So if I look at metrics and I refresh, now when I refresh, I can look at the significance of all of those metrics that you see here. I have 3 stars, I have 2, I have 1. So for each of these coefficients, I have a significance value, and it's a central repository of your runs, coefficients, and the significance values. The next step after training a model would be to save the model's pickle file into the output folder and upload it to artifacts. So the first step is uploading it to the output folder, which is what we have here. So currently it's empty. Once we run the save command and we upload it to the artifacts, we can refresh it and see that the pickle file has been uploaded here. Once we've uploaded the model to the output folder and uploaded it as a metric, we would want to update our model registry with the latest model, because that is how we would deploy the model to a cluster or to a Azure machine. So we register a model with a model name. If there is a model already registered with that name, it will just update or create a new version of your model and give it a version ID. So here I already have a model name. It will give me a new version of that model. And you can also look at older versions and see all the versions of your model. So if I look at model.list and give the name of the models, I'll have a list of all the models that have already registered. Once all of that is done, so here if you see, I have multiple models here. I have quite a few that I've uploaded, and along with that, I have a version tag which tells me what is the version of the model that I'm currently looking at. Once all of this is done, we'll end the experiment and give it a success ratio or a quota. So I do that through the run complete command. Now, if you go back to Azure Machine Learning Studio and refresh, you'll see that the run command has completed. Coming to the part of how do we deploy these models. We've trained the models, we've uploaded the model to the registry. The next step would be to deploy the model to a cluster so that you can use it in your web applications or day-to-day applications. So to do that, the first steps would be pretty much the same. You'd import the libraries, you'd connect to the workspace. Now, whatever you've uploaded into the model registry, you want to download that into a local place. So in our case, we're downloading it to Databricks' local workspace. We're giving a model name. So here I'm using another model, and I'm downloading that. The next step would be to create an entry script. The entry script is significant and very important here because that is what loads your model and is signifying how your model will be interacting with the endpoint or the deploy cluster. So here we have an initial or init function. This essentially imports the model from the registry or the downloaded registry and stores it in a local space. The next step would be the run command. So the run function takes in the data from the queried endpoint through the API call and triggers or calls the model to predict the value and then returns it in the REST endpoint. So the entry script is something that can be auto-generated from the model itself, or you can also tinker it and create your own entry script if you want to modify your changes. We create an entry script, store it locally as well. The next step would be to create a conda dependencies file. What this file essentially tells you is it lists out all the dependencies that your model would have, both conda and pip packages. So in this case, we have NumPy, Pandas, and scikit, and our pip packages are Azure ML SDK because we're using Azure as our training workspace, and inference schema, some basic pip packages. So in case you've trained it over a neural network using TensorFlow, you would have those dependencies listed out here as well. Now you've created the conda dependencies file similar to how you created the entry script file and stored it locally. Both of these files constitute what is called an inference configuration file. So the inference configuration file is what is used by your cluster to initialize the cluster and to load up everything properly. So the next step after creating both of these files is to create a cluster and use the inference configuration to deploy your model. So the first step after we're doing that is to create a ACI machine here. So we're giving the information about the number of cores, the memory that we want for the ACI configuration, and the name of the service. The next step would be to check if a similar or same named ACI exists. In that case, we'll delete it. Otherwise, we'll create it normally. We'll provide the dependencies as the inference configuration, and then we'll deploy our model to that service with the inference configuration. This takes about 5 to 10 minutes based on what kind of configuration you have and the time it takes to load. Once that is loaded up, you get a URI. You can also check this URI through the Machine Learning Studio. You go to your endpoints in your Azure Machine Learning Studio. You click on the service that you have. Once you click on that, it displays all the details about the ACI. So here I have the REST endpoint URI. You can use this URI across all of your applications. So this is the URI that I have. Now I can create a sample test case to check if everything's working fine. So here I've created a sample test case with all the parameters that my model would expect. I would trigger or call the API for that URI, and I would get a predicted value of results. So 0 would be that it's a false claim or it's a negative claim that would not be accepted. And you can use these API calls or this REST endpoint across all of your applications. You can use it across Power BI, Tableau, etc. Now, in case you want to update your model or you would want to create a model with better efficiency over the same endpoint, you wouldn't go ahead and delete the ACI configuration and redo all the steps you've done. All you can do is you can just update the model with the inference configuration. So your entry script might change. You've updated your model to expect more parameters. That's why you're updating your inference configuration, which is constituting of your entry file. Maybe you've changed the model to use another library. Maybe you've shifted from TensorFlow to PyTorch. So in that case, you would update your inference configuration as well, and the model that the ACI should refer to. You'll just got the update command, and it'll update the service. It'll restart it, and your URI stays the same. So this URI that we received, it stays the same. In case you delete it, there is a chance that your URI might change. Yeah, that pretty much covers everything else. Back over to you, Andrew.
Okay, thanks, Jazz. So if we're showing us through the model repository and how we write into that model repository, what I want to do now is take a look at how we use some of the existing DevOps tooling from Azure. What we have here is Azure DevOps. If you want to take a look at it, dev.azure.com is the address. You can sign up for a free account there with the ability to do quite a few things through that, actually. So what we've got here is a series of steps. You can see the first one here is just telling it to use Python 3.6, installing some of the Python libraries, and kind of step-by-step walking through it. So when we check our data source, load the new data in, we can run some tests on the new data. And you can see here that logo means that we're publishing the test results into Azure DevOps. And if I were to go into to look at the build pipeline in more detail, it will show me what percentage of those tests that I published have passed. But ultimately, I'm writing and running tests that are running using JUnit testing, so we're writing it using Python in this case, running over the data source. From there, we start to use Azure ML, so we build in the CLI. We use our Azure ML compute cluster, we upload data, and here's the big important part. We're training a model using Azure ML compute. Very similar to the script that Jaswy showed us a minute ago. I've got a Python script here. In this case, it's trained diabetes. It's running a model to predict the probability of someone having diabetes based on their health markers. But we pass up the Python script that it's going to run. We pass up those other files, the conda dependencies file is the key one there. And using that just passes it across to Azure ML. So similar to what Databricks was doing if we run that notebook, Azure ML can run this, generate a model, and then it will do the same thing. It saves the data from that model into the same model registry. So actually, whether we built the model in Databricks, we built it in Azure ML, we're able to save the model details into the same model registry using this build pipeline. From there, we can download the model so that we're ready to use it. We're ready to publish that model into production. And so I'm not going to do it right now because it does take a minute or two to run, but if I wanted, I can just press a button, queue that run up. That will bring the latest set of data in, build the model, run the validation steps, publish the results so I can check the validation steps. From there, I can run a release pipeline, and I can either have that trigger automatically, or I can have it drop someone an email, or have it like I have in this case, so that here it's waiting on an approval before it publishes. So the build's complete. I want someone to go in and check that. And from here, I'm going to press the approve button, and that will kick off the actual deployment. Again, if I take a look into this release, it's a very similar thing, similar set of steps. Again, using, if I go into one of these, deployment succeeded. You can see here the different steps that it's gone through. So again, we're telling it to use a Python version. We're telling it to add the Azure ML extension. And this deploy model is going to deploy it into, in this case, I've got it set up to deploy into an Azure Kubernetes service. And I can create that as part of the process as well if I wanted. So if I wanted a new Kubernetes process to keep a new version every time I deploy a new version of the model, I can build that into this process. So we're able to control not just machine learning stuff, because this is the wider DevOps tooling. I can have it control my infrastructure code in the cloud as well. And I can have it potentially even running the application that users use to access the machine learning models. So depending on how we want to use it, we can go really wide and use this for a whole host of different steps that we run as part of the process of publishing. So hopefully that's let you see a little bit within Azure DevOps and see how we use that tool alongside Azure ML and see how the two tools work together to give us those capabilities for machine learning. What I want to do to finish off is quickly take a look through some of the MLOps practices and some of the considerations that we need to think about when we're doing it. So if I return to this list of 8 and call out some of the things to think about, for all of these really, not just the CI/CD, you want to think about what tools you're already using. How do we make use of those tools better to support some of these things to optimize our processes? And then are there tools that we can easily add on top to optimize what we're doing? So that we take processes that we've got at the minute and just bring those to a place where they're optimally delivering value quickly. For things like retraining and alerting, I've hinted at it a couple of times. We want to think about how often those should be retrained or what are the triggering factors for them. And key alongside that as well, for both retraining and for evaluation, how much of this do we want to automate? How much can we automate? Versus when do we need to trigger an alert? When do we need to trigger an approval for someone to go and take a look at something and do manual checks? So we know in a number of industries there'll be industry regulation that means that you need to be able to to vouch for your models, you need to defend your models and to actually explain where they've come from and how they work. And in those cases, that may have an impact on how you run some of the evaluation. Alternatively, if you're running something internally and only using it for kind of informal processes, maybe highlighting the cases that you want to look at internally and prioritizing work cases for support or something, for example, it may be that it's more valuable to have that up to date and to, you'd have someone go through and check it every so often, but have the up-to-date model published maybe every few days, every week, based on the latest data that's coming through. So different use cases, different industry positions as well will make a difference on how much of this life cycle you can automate, but it's valuable to think that through. And in terms of getting started and finding what works for you, the key thing I think is to kind of pull it back to these headline goals. So again, the definition of the thinking we're doing here is about philosophy and technologies to streamline, in our case, the machine learning lifecycle. And we're looking at those three goals at the bottom. How can we reduce the time to deliver value? How can we respond to business opportunities quickly? And how can we deliver that step change in productivity? So the tools and the technologies and ideas around the people and the processes are there to do it. It's about finding what works for you, what you can quickly implement to bring your productivity level, to the next level. So how to do that in terms of a list of practical steps. Start by reviewing your existing project lifecycle. Where are the bits that are taking time that can be sped up, either by changing processes or bringing technology in to support that? Identify places in the tool sets that you're already using that you can optimize processes, and then look for other tools that sit alongside those that help as well. It's important to remember in all of this, MLOps isn't all or nothing. I guess some of what I've shown today might look like it's daunting or scary if you're just at the minute sitting building your R and Python scripts on individual machines. There's a big piece of work to get to that point, but MLOps isn't all or nothing. Figure out what works for you and your organization. What does it make sense to implement now? What are the first things that are going to give you that next step up in terms of the productivity levels? And then as you go forward, keep evaluating and looking for more opportunities to work towards those goals. At any stage in that process, we're very happy to help you with that. We can have conversations about your current process, what's working, what doesn't work within that, and how you can optimize. If there are questions around tool selection, we've worked with a whole range of different machine learning tools in the past. And in terms of bringing in the different DevOps technologies in alongside that, we can help you think about tool selection, deployment patterns, and architecture design. I'll wrap up the webcast there. Thank you for listening. Thank you for attending today's session.